Okay guys, I'm going to look at the homework you sent me first. We're going to do the corrections and then, but as you are busy with the video, while you're copying this, stop the video and then play it again. Okay, so the first few of these that we have done, now I know this is confusing, but you guys tend not to check that the decimal is the same right through. So in order to get the same decimal, I need to get the sevens over there. So instead of going with 10, I'm going to go with 100x, and that will give us 13,777 and so forth. But these two decimals are not the same. So that means that I need to find another one. So now I'm going to go with 1000x, and this will give me 137 and the same decimal. Now we have, so the main objective here is to get the decimals to be the same. So here we have the same decimals. So these are the two that we're going to use. Now keep in mind that we have to subtract them from each other to create what we an integer. So 1000 minus 100 is going to give us 900x. And over here we have 137 minus 13. So 137 minus 13 is going to give us 124. And then I need to simplify this, and this is 124 over 900. So using the calculator, I will punch it in like that, 124 divided by 900, and that simplifies it to become 31,25. Now just to check that I have the correct answer, I need to, on the calculator, press the SD button just to confirm that, and there you can see we have the 0,13777 and so on. Okay, so the next one was this one. Now the same applies here. Only the 37 and the 37 repeats itself. So again I need to get them the same. I'm going to multiply this one by 10 now. So 10x is going to give me 1,373737, as many as you feel you need there. But I cannot use these two because the decimals are not the same. So I have to get another one, so I go with 100x now, and that is 13,73. Sorry, my mistake. I'm moving it one place, so I have 73. So now it looks like that. Again, I don't have the same decimal here. So I have to go with another one. So this is how I got to 1000. So I'm multiplying this one by that, and that gives me 3737 and a 37 at the end here. And I have the same decimals. Here are the same decimals. These two, that one and that one, have the same decimals. I need to get the same decimals. So subtracting these two from each other, I will now have this. 1000 minus 10 will give me 990x, and 137 minus the 1 is 136. If I simplify this, 136 over 990, again I'll use my calculator to see if it's simplified as far as we can go with it. So 136 divided by 900, and it simplifies it to 34 over 225. Again, use the calculator to see if you got the correct answer. I put it in correctly. And it's like in 34, 136 divided by 990. Okay, there we go. So this is completely wrong. That is going to give me then 68 over 495. So you need to make sure that you get the same decimals. This one you got right, both of you, except you made a silly mistake at the end. Just go and check that. These ones can also be written as fractions. Any fraction, this can be written as 4 over 1, minus 7 over 1, 0 over 1. So any number can be written as a rational number. That means that the numerator and denominator are both integers. 2.10, here's the same one that we had previously. I'm just going to do this one again. I need to get the same decimal, so going with 10 will not help me, so I'm going to go with 100x. That means that the decimal will move 2 spaces. So this will be 2, 21, 21, 21, 21. Clearly we can see now that we have the same decimal. And once you have the same decimal, you just have to write that down then. So this is 100x minus 1x will give us 99x. 221 minus 2 is going to give us 219. That means that this will change to 219 over 99. Again, calculator. 219 divided by 99. And if I press the SD button, it gives me 2,212121. And that is what we were looking for. You will also notice on your calculator that the answer was simplified to 73 over 33. So we need to do that as well. Okay, then with this one, there was a bit of confusion when multiplying out these brackets. So make sure that you have this right. I'm multiplying 3xy to 6xy. So 3 times 3, 3 times 2 will give me 6. X times x, x squared, y times y, y squared. Now we're done with the first one there. Then we go with the first one and the last one. 3 times minus 3 is minus 9 x, y, z. Keep this in alphabetical order. It is just easier to see what are like terms and what are not. Multiplying these two, 4 x, y, z, and then multiplying the last two, 6z squared. You will notice that the two middle terms are like terms. So minus 9 plus 4 is minus 5, x, y, z, minus 6z squared. The next one, 311, I think the confusion here was just because of the fractions. Use your calculator to work out the fractions. 2 times 3 is 6, 6x squared. 2 times minus a half will give us minus x. A third times 3 gives us plus x. A positive times a negative is a negative. Numerator with numerator, 1 times 1. Denominator with denominator, 3 times 2 is 6. The middle two, again, are like terms. They are additive inverses. Additive inverses means that if you add them together, they give you 0. So my final answer would be x, 6x squared. That part falls away. Minus 1 over 6 is left. Then to this one, I don't know why this one was, you messed this one up. Remember to write out the brackets twice. And then we do that multiplication. So x squared plus x plus x plus 1. These two are like terms again, but now they're not additive inverses. That means that if you add them together, they don't add up to 0. And this will give me x squared, x plus x is 2x plus 1. The same with this one. We're going to write the brackets out. 1 times 1 is 1. 1 times that is minus x, y, z, minus x, y, z, plus x times x, x squared, y times y, y squared, z times z, z squared. These two can be added, but remember, if we add like terms, we do not change the powers. That only happens if we divide or multiply. So this is 1 minus 2 xyz plus x squared y squared z squared. No change in the powers here. No change. Same as with this one, we're going to write out the brackets twice. X plus AB, x plus AB. X times x squared, x times AB, ABX or XAB, but having it alphabetical order is just easier. Then multiplying these two will give us another ABX, multiplying those two will give us an A squared, B squared. Now we can add the two middle terms, but no sign changes. It's one of these plus another one of those will give us 2 of exactly what we start out with. Nothing changes here. No power change. We're not multiplying. Then with this one, I think again the fractions was the issue here, and the fact that you can't use your calculator makes this then more difficult. M times m is m squared. Now I'm multiplying m with 1 over m, but keep in mind that we're really multiplying with m over 1. Numerator with numerator, denominator with denominator. So this gives us m over m. Then going across to this one, the same here. This is really m over 1. 1 times 1 is m times 1 is m, and that times 1 is 1 over m. Now you will notice that in the middle here, m over m is 1. So that means that we will have m squared plus 2 plus 1 over m. Then to this one. Both of you messed this one up pretty badly. Leave the first one as it is. Do not touch this one. Only look at the last two brackets. So I'm going to put this bracket down here, not doing anything with it yet. Start the bracket again because I have to multiply all of this out. 2x times 3, 6x. 2x times minus 8x is minus 4x is minus 8x. Then the 1 is multiplied by 3, and the 1 is multiplied by the 4x. Still, this one stays as it is. I'm not touching this. I'm going to simplify the inside of this bracket first. So here we have 6x minus 4x is 2x minus 8x squared plus 3. Now we're done with this bracket. It's a simplified as you can get it. So now we're going to multiply this bracket in. Only now we involve this. Keep in mind that you have to multiply this to each one on the inside. We just go with this. So I have to multiply it there. I have to multiply it there, and I have to multiply it there. Then the same applies to this one. I have to multiply it there. I have to multiply it there. I have to multiply it there. So only now the front bracket is involved here. Let's go with that one. X times 2x, 2x squared. X times minus 8x cubed. X times the 3 at the back is 3x. So that is for the blue highlighter. Now the purple highlighter, minus 3 times 2 is minus 6x. Minus 3 times minus 8 is plus. 3 times 8 is 24. X squared. And the last one is minus 3 times plus 3 is minus 9. Now we need to look for like terms. Remember that like terms, same base, same power. So there's a 2x squared. There's a 2x squared. Here we have an x. And there we have an x. The cube is on its own. So 2x squared plus 24x squared is 26x squared. 3x plus minus 6x is minus 3x. Then we have this one, and then we have that one at the end there. This one was also confusing because you try to do one thing at the same. Leave the negative until you're done with the brackets. So there's my x plus 1 and x plus 1. You see I'm doing this already. The negative stays there, not doing anything with the negative. The same applies to this one. Minus 3 and like that. There's my negative. The negative is still on the outside, not involving it at all. So x times x squared, x times 1 is x, 1 times x plus 1. Over here, minus times a minus is a plus. Minus times a minus is a plus. And now you can multiply in the negative to each term on the inside. Or you can simplify them first, which I prefer because then it's less to do in the last thing. Now remember that this negative must be multiplied. The negative in front of the bracket must be multiplied to each term on the inside, not just the first one. We're really multiplying with a minus 1 in front. This is also a minus 1, and I multiply it there, I multiply it there, and I multiply it there. Minus x squared minus 2x minus 1. Minus x squared minus 6x minus 9. Now we can add like terms. Minus x squared minus 2x squared. Minus 2x minus 6x is minus 8x. Minus 1 minus 9 is minus 10. Now we're done with this. And this was the last one. The last one again caught you out because you forgot to leave this one until the end. I'm multiplying out these two brackets, x times x squared, that times that, xy, that times that, minus 3xy, and that times that, minus 3y squared. I'm going to do this in one step. So I multiply 2x to 2x, that gives me 2x squared, times the minus on the outside, minus 2x squared. Then I multiply the 2x to the y, so that's 2xy times the minus is minus 2xy. If you struggle to do this in one step, do it in two steps. Minus x times minus y times x is minus xy times the minus is plus xy, and minus y times y is minus y squared times the minus is plus y squared. Close the bracket. The bracket that's in front here stays here. I'm not going to bother with that unless I have simplified everything inside here. Check for like terms. X squared minus 2x squared. Let's just go with a different color. X squared minus 2x squared is minus x squared. Here we have 1. Minus 3 is minus 2. Minus 4 is really minus 5. Plus 2 is minus 3. Minus 3xy, and then minus 3y squared plus y squared is minus 2y squared. And only now do I involve the bracket in front by multiplying whatever I have here. Let me just change this back. Okay, so x times minus x is minus x cubed, x times that is minus 3x squared y, and x times that is minus 2xy squared. So that's for the arrow, the purple arrows. Now let's go with the blue arrows. So we multiply there, we multiply there, and we multiply over there. Y times that is minus y times minus is plus x squared y. Note, I'm still sticking to alphabetical order. That times that is plus 3xy squared. And the last one would be plus 3y cubed. like terms. Be careful when nominating like terms that you don't get confused with this. Here's the x squared y, and here's the x squared y. Here we have xy squared and the xy squared. They are not, the green and the yellow are not the same. So make sure that you don't get confused with that. Let's go with the red. Looking at the yellows, minus 3 plus 1 is minus 2x squared y, and that plus that is plus 1 xy squared plus 3y squared. Then we get to today's lesson, and that is factorizing. Just want to check how much time this took. Too long. Okay, so the first thing we need to look at is highest common factor. Then difference of two squares, and then trinomial. And then we do, after this we do grouping. So I've picked a few examples that we're going to do. So this you need to make sure that you do it in that order, check for them. So the first one we have to look at is always look for highest common factor. Now 2 is a common factor of 4 and of 8. But we're looking for the highest common factor. So the biggest number that can divide into 4 and to 8 is 4. So that comes on the outside of the bracket. Inside of the bracket, we will have whatever is left. 4 times what will give me 4a, and that is 4 times a. 4 times what will give me 8, and that is 2b. And that is done. So once you have removed your common factor, check inside if there are anything left. This one is more difficult because we're dealing with different powers. So let's just go with the numbers first. What is the biggest number that divides into 5 as well as into 20? And that would be 5. You can see we have an x here and an x here and a y and a y. So xy is definitely going to be my common factor. But here's the key. Your highest common factor of letters that are repeating with different powers is the one with the lowest power. I'm going to say this again. The highest common factor is the one with the lowest power. So if I look at x, the lowest power of x is 1, so that would be just x, or x to the power of 1. Looking at y, there's a y cubed and a y squared, so that gives us a y squared. Now I just have to go and check what is left after I have removed this here. So the 5, there's no 5, we short a x and we short a y. Over here, 5 times 4 will give me 20. The x is already there, the y is already there, there's your final answer. So once you've done this, multiply this in and see if you get the answer that was on top. This is still grade 9 factorization, but we have to look at that again. Okay, so having more than one term as a common factor, you can see that the two brackets are very similar. They're not the same though, because this is a minus b. Just a reminder here. 2 plus 7 is the same as, let me just give a bit more space. 2 plus 7 is the same as 7 plus 2. But 2 minus 7 is not the same as 7 minus 2. So that's why these two are not the same. If those were to be pluses, no issue. But it being a negative, that is a huge issue. But we can make them the same. I don't know if you can still recall this from last year. If I want to swap the two around, I change the sign on the outside, and then you can swap them around on the inside. So now we have a common factor of the bracket is the common factor. So there's the common factor. I'm going to put the common factor in front. So there's my common factor, a minus b. What is left? There's a c left, minus, and then, this is something that we tend to overlook. There's a 1 in front here, or really a minus 1, and that minus 1 goes into this bracket. And now that is factorized. 7.3. You can see we have the same scenario here. We have a b minus c and a c minus b. But there is something else here with this. So we'll come back to that. Let's just focus on the brackets for now. From the previous example, we know that we can swap these two around, but then we have to change the sign in front. So this will stay 3/4 a, b minus c. Now the negative on the outside changes to a positive. And that allows me to swap around c minus b to b minus c. Now you will notice that we have a common factor of the bracket. This is a common factor, but also we have another common factor here. There's a quarter as a common factor in both of them, so I'm going to remove a quarter as a common factor as well as the bracket. So there's my common factor. I've removed a quarter, so there's still 2 quarters left, or a half left. 3 left. 3a is left. A quarter times 3 will give me 3/4. And over here, a b is left. A quarter times b will give me a quarter b. 7. Now here we have a lot of terms. In fact, we have 6 terms. I would suggest that you check what is repeated, see if we can remove all of that. So at first glance, I thought we could remove an m, but there's no m here. If I group these 3 together and these 3, note I'm not drawing brackets around them, because drawing brackets around them will change your signs. I'm just going to look at the first part in blue and see which ones are what I can remove as a common factor. So the blue one, I can remove m squared as a common factor. Remember what I said earlier? If a letter is repeated in each one, I can remove that as a common factor. And then I just have to check that I use the one with the lowest power. So lowest power, highest common factor. So over here we're left with a minus bm plus cm squared. Do you see that this is almost that, except the signs there are the wrong way around? There's my negative, so I'm going to remove a negative on the outside as a common factor, or to be more correct, a -1. That will allow me to get what I have here. So that is a minus bm plus cm squared. Now you can clearly see that we have this and we have that as a common factor. We have the common factors. The common factor would be the 2 brackets. And then I'm going to put that in front. A minus bm plus cm squared. Here we are left with m squared, and here we are left with a -1. We're not done yet, because this is a difference of 2 squares. We have not done any of those yet. But we factorize them like this. It's the square root of the first number minus the square root of the second number. And then in the other bracket, we will just have a positive. So now we're really going to do the difference of 2 squares over here. Square root of the first number, square root of the first number, square root of the second number, square root of the second number. One bracket is negative, one bracket is positive. Doesn't matter which is which. The same applies to this one. Square root of the first number is a squared minus and plus. Square root of the second number is 9 and 9. But now we have to be careful not to overlook something that can be factorized still. This is a difference of two squares again, so that we can split up again. This one is a sum of two squares, no factors here, no factors. That one stays as it is. So there's the a squared plus 9. Square root of a squared is a, square root of a squared is a, minus 3 plus 3. That remains the same. Square root of 16 is 4. Square root of g squared is g. Square root of t squared is t. Square root of 81 is 9. One bracket positive, one bracket negative. 9.3. Now this one becomes tricky because we have to look at the whole bracket now as a perfect square. Note I'm using square brackets. I'm going to look at the last one because that is the easiest one. The last one is 1. Square root of 1 is 1. One bracket is positive, one bracket is negative. Now the square root of a bracket squared is just the inside of the bracket. Nothing is multiplied to this bracket, so this is d minus b minus 1, d minus b plus 1. No change here. That stays the same. 9.7. Square root of 4 is 2. Square root of the bracket, 8b plus d. Let me just start over because I'm going to run out of space here. 2 times the bracket, 8. There we go again. 8b plus d. That's for my first bracket. I will have the same one here. One bracket is positive, one bracket is negative. Now we're with the second term. So this would be 5, 2b minus d. This one would also be, but now positive, 2b minus d. I need to multiply, simplify the inside of these brackets. 2 times 8 is 16b plus 2d minus 10b plus 5d. Same in this one. I'll multiply that out. 16b plus 2d plus 10b minus 5d. In each bracket collect like terms. 16b minus 10b will give us 6b. 2d plus 5d will give us 7d. Same applies here. Just check if I've done this correctly. Okay. 16 plus 10, 26b. 2d minus that is minus 3d. And now we're done with this one. Now we're getting to trinomials. Now the trinomials is something that you have done last year, but I know that this is always a tricky one. I look at the number at the back. The number at the back, if this is in the correct order, so from highest to lowest, I write down the factors of 12. 1, 12, 2, 6, and 3, 4. Now I need to look at the combination there that if I add them will give me 7. And you can see clearly that it can only be 3 and 4. since this is positive, it means that we're adding. Since this is positive, it means that the signs will be both positive. Now this one is still 12, so we're going to use the same factors. 1, 12, 2, 6, 3, 4. But now this one says that the factors of 12, that if we subtract them, will give us -1. So the only one that will give us a difference of 1 here is 3 and 4. So 3 goes there, 4 goes there. They can go anywhere you like. It depends on what the sign is going to be. The negative here says that the signs will be different. The negative here says that the biggest one will be negative. So the negative will go with the bigger number. This is a grade 10 question that you could not do last year. Now we need to consider the numbers there and there, not just the last one. So the factors of 2 is 1 and 2. Then I draw a line in between to separate that one from this one. And here we have the factors of 2 and 2. It is a trinomial. Now these ones will take a while for you to get right. This is more like an introduction to this than anything else. If I multiply 2 and 2 to each other, that gives me 4. And if I multiply 1 and 1 to each other, that gives me 5. 4 plus 1 will give me. So we have 2 times 2, 1 times 1, and that gives me 5. And the 5 is the 5 that we're looking for there. So the 2 is multiplied to the 2. So that means I will have a 2 here and a 2 there. I will have a 1 here and a 1 there. I realize that this is difficult. We will do a lot of these still, so don't stress about this. So just to check if this is correct, 2 times x is 2x, 2 times 2 is 4, 1 times 1 times 1 is 1, 4 plus 1 is 5. So my answer will look like that. So I'm not going to give you homework on these because we're going to need more of them. This is just an introduction that you can get used to this. Factors of 8, so we're looking at the number 8. 1 and 8, 2 and 4. And then at the numbers at the back, here we look at 15, 1, 15, 3 and 5. We have to subtract to get 14. Now check my reasoning. 8 times 15, that's going to be way too big, so I don't even have to go there. 8 times 1, can you see I've tried it like this, but this is going to be 80, 120. Not going to work. Subtract 1 is 119, so now I go across. 8 times 1 is 8. 1 times 15 is 15. The difference between 8 and 15 is 7. We need to get 14. Now I use the 1 and 8 again, but I'm not going to use 1 and 15 again, I'm going to use 3 and 5. 8 times 5 is 40. 1 times 3 is 3. 40, the difference between 40 and 3 is 37. We need 18. Now I'm going to go across like this. 8 times 3 is 24. 1 times 5 is 5. Can you see why you were taught the tables in primary school? 24 minus 5 is 19. Not going to work. So it seems to me 1 and 8 is not going to work. So now we're going to go with 2 and 4. 4 times 15 is 60. That's already too big. We don't even have to consider anything more there. 4 times 1 is 4. 2 times 15 is 30. 4 and 30, the difference is 26. So the 15 is not going to work. So now the 1 and 5, 15. So now we're going to go here. 4 times 5 is 20. 2 times 3 is 6. The difference between 20 and 6 is 14. So multiplying the 4 to the 5 will give me 20. Multiplying the 2 to the 3 will give me 6. The difference between 20 and 6 will give me 14, and this is what I'm looking for. Now we still need to put them in the correct brackets. This is the x side. So that means we will have 2x and 4x. So here's 2x, 4x. This is the constant side. But the 2 must be multiplied to the 3. The 2 must be multiplied to the 3. So the 3 can't be here, the 3 must be there. And the 5 must be 10. Now we need to look for the biggest product. 2 times that is 6, this times this is 20, so this one is negative and that one is positive. Just to make sure that you got this, then I'll get 20x. Over here I'll get minus 6x, so that will give me the 14x I was looking for. These ones are difficult, I know. Okay, so here we have another one, except now s is involved here as well. Just want to check time. So we're looking at 2 and we're looking at 20. 1 and 2, 1 and 20, 2, 10, 4, 5. Those are all the factors of 20, the integer factors of 20 that we can find. So we need to find a sum of 13. So with time, obviously, you will get this. I know that 2 times 20, that's already too big. 2 times 10, that's too big because you have to find the sum. So I'll have to go with the last number here. Going with the last number, 2 times 5, that will give me 10. 1 times 4 will give me 4. So that will be 14. But we need to get 13. So obviously that is not what we have to use here, or what we can use here. So I'm going to just remove that. If I cross multiply, 2 times 4 is 8, 1 times 5 is 5, 8 plus 5 is 13, and that one is going to work. So here we have 1r and 2r. You can write the 1 in front if you like, 2r. The 2 must be multiplied to the 4. Therefore, the 2 and the 4 can't be in the same bracket, so the 4 goes here and 5 goes there. Having a positive here means that the signs will be the same, both negative. And that was the last example. I would like you to do the following for the next, you need to have this finished by the end of Tuesday, before Thursday. So number 6, except the ones I've done for examples, number 6, number 7, number 8, number 9. And then in number 10, just up to 10.9. So don't do the last 3 we've done on the board, because they involve this, and I would like to explain that to you more in person before we do that. So just to repeat that, number 6, all those we have not done, 7, all those we've not done, 8, the ones we haven't done, and 9, the ones we haven't done. Then in number 10, 10.2, 10.3, 10.5, 10.6, 10.7, 10.8, and 10.9.